Welcome to PhyLab application. In this tutorial, we will be looking at how to perform transistor characteristics on our PhyLab application. From the home page, find the transistor characteristic card and select on the simulator button. It will open simulator for you. The first dialog box is the aim of the experiment, that is to study input and output characteristics of the transistor. Close this dialog box, then you will be greeted with a circuit and you need to connect all the wires as per the circuit. So the operators is specifically designed to for this experiment, which is to observe the transistor characteristics. So here we can connect all our connections as per the circuit. We have on the left side and right side there are two knobs, black knobs. Those are the batteries. So consider those are the batteries and positive negative terminals of the batteries and connect the remaining stuff. So the first thing is the negative terminal of the battery is connected to the emitter of the NPN transistor. So here two batteries negative terminals are connected to NPN transistors. Click on the terminals where you want to connect. So the wire automatically gets connected for you. And the next step is the negative terminals of the voltmeters are connected to negative terminals of the batteries. So let's connect negative terminals of voltmeter to the negative terminals of the batteries. And next step is positive terminals of the two voltmeters are connected to corresponding positive terminals of the batteries. And next, positive terminals of the two ammeters are connected to corresponding positive terminals of the batteries. Next, negative terminals of the milliammeter is connected to the collector terminal of the NPN transistor, and negative terminal of the microampere is connected to base of the NPN transistor. So that's it. Click on the submit button and it will validate successfully. Then start with input characteristics. For input characteristics, we need to set the VCE voltage at a constant voltage. So to start with, we will set it at 2 volts and then we vary the VBE voltage to measure the IB value. So enter VCE values at 2 volts, whichever you set now, and then use the left hand knob to change the VBE voltage. So set the VBE voltage to 0 millivolts and observe the ammeter reading. So here we will start with 0, 100, 200 of VBE voltages, okay, 300 and then 400 and then 500. From 500 we will go small steps like 520 and then 540 so 540 there is a small change in the ammeter, then 580 and then 600 and then 640. So once you are done with till 640, again change the VBE voltage to 4 volts and then repeat the same experiment like 0, 100, 200, 300, 400 and then 500, 520, 540, 580, 600, 640. Again, after entering all those values, change the VC voltage to 6 volts. Again repeat the same process, like for each constant voltage, like 3 steps, 3 iterations we take, and then we measure the IB value by changing VBE value. So this is the same experiment repeatedly we need to do it. And once you're done with all your observations, we need to start with output characteristics. So I am filling out the last value here. Yeah, next is output characteristics. For output characteristics, we need to keep the IB value as the constant value. That is, we'll start with 25 microamperes. Set the IB value to 25 microamperes and enter that value. And then we'll keep on changing the VCE value like 0 volts, 1 volt, 2 volt, 3 volt, 4 volt, 5 volt, 6 volt, 7, 8, 9. So like that, for each value we will observe the IC value. So IC value is in milliamperes. Okay. For each voltage, like for each VCE value, we will measure the IB value from 0 to 9 volts. So here I am noting it for 5 volts and then 6 volts and then 7 volts and then lastly 9 volts. So after you're done with all the 9 volts, next step is we need to change the IB value to 50 microamps. And then repeat the same experiment like VC value from 0 to 9 and then measure the all milliamp values. Again set the microamperes to 100 or 75 and then repeat the same experiment again. So note down all the values and at the end you will be greeted with a calculations panel. So in the calculations panel, these are the all values for input characteristics. For different VBE values, for constant VCE value, we measure the IB value. So by using the graph icon there, we can start plotting our graph. Let's click on the graph icon there. The graph will be open for you and it will contain a graph paper and all the values on the right side. And by using all those values and the tools provided, you can start drawing your graph. By using this mouse scroll wheel, you can zoom in and zoom out the graph paper and then you can click and drag the graph paper. So we provided two modes, one is pointer mode, another one is line mode. So to place the dots, you should be in the pointer mode, click on the pointer and then place all your dots. And when you drawing the lines, you should be in the line mode to draw all the lines. So enable the pointer mode now. So I am actually pointing all the values. Click on the place where you want to put the pointer. So here I am drawing for the first value 520 and then 540 is for 2.5 and then 580 goes to 5 and then 600 is to 10, 640 is to 60. So I enable the line mode and then start clicking from the start point and dragging in the direction where you want line to be. And then I started with another set of values. Again, I am enabling the pointer mode here and setting all the values. So this is how you need to actually plot the graph for three different set of values for input characteristics. Remember, whenever I want to drag the graph paper, I should not be in either line mode and also in pointer mode. So once done all the calculations, there is from 0 to there is a sudden increase in the voltage, right? So first draw a line where the sudden increase is onto x-axis, and from the intersecting point draw onto the y-axis. Measure the distance where exactly that line is intersecting on x-axis and y-axis. Those will be our delta VB and delta IB. So for delta IB it is 10 amps and for delta VB it is 60. So the divide voltage by current, we get the input resistance. So done. We are done with input characteristics. After that, you need to perform the same operations. Prepare a graph for output characteristics. Click on the button for the output characteristics and you will be greeted with the graph again. So here you need to draw the graph for output characteristics. Enable the pointer mode and place all the pointers here. For corresponding voltage values and plotting the points for current values. So it will be most probably like a straight line from 0. It will increase to a particular voltage and then it will be a straight line. And draw a graph for multiple values. So once you plotted the graphs, we need to calculate delta VC and delta IC values. So we will take a place where exactly the constant, just before the constant current is emerging. So from there and then the constant temperature. So we will take the delta between these two values and plot those values on x-axis as well as on y-axis, so that we will get delta voltage and delta current values. Here I will be measuring the delta current value. It is the difference between the two intersecting points there. It is 12.7 minus 15 point 14 point something is 1.6. So delta IC value is 1.6 and delta VC value is 4.2. So divide those two values, we will get the output dynamic resistance. So then we will calculate the current gain. Current gain is division between the delta IC with delta IB. So once you are done, submit your all calculations. The tool will validate all your calculations and it will upload to the cloud if they are valid. And once they are valid, after successful uploading all your graph and data to the cloud, you will get a pop-up message saying congratulations. If not, then you will get an error message. You need to re-perform the experiment again. So it will take some time to upload depending upon your internet speed. Once you get the dialog box, close the dialog box. You will go to home page And from here again go to the Transistor Characteristics card and click on the Downloads button. So it will prepare a PDF report for you with all your data and graphs and then download it for you. So you can use this PDF report to print on a paper and then showcase to your teacher that you performed this particular experiment successfully and these are all your values and observations. So let's open the downloaded graph now. We can see how it